interfaces. You don't count, but yes, okay. And how many of you know what that means?
Stepped away from the countdown, which
Yes.
is fine. So I clicked on the scene, which is his computer, yes? Hey, Mark, your computer is live, though.
So you clicked on the scene.
No,
Yeah, you're on scene.
yeah, but his computer's live, and we haven't started yet, so we need to go back.
Oh, no, we have started.
Well, we haven't started.
You haven't hit the live thing on YouTube? Because we're recording this right now as we speak. In fact, my audio is going. Okay, details.
Okay. Let's
need
go
to
back
figure
to
out-
the countdown so that people don't think they're not hearing.
We starting? Am I starting?
Aaron said you didn't need to tell the truth, so you can say good things.
So I can say good things this time about you? Okay, perfect. Somebody want to give me a thumbs up? Should I wait? I can do a little song and dance number. Nobody wants that though. It's okay, that's how I see normally.
There's a button on the left-hand side. You just click it. Autofocus.
It's like the put the glasses on in front of the camera moment.
You didn't get your timing right.
That would have been perfect. We'll rehearse that next time. Like,
Nope.
glasses on. The online feed now gets clear mode. Should I hold still? Should I move? I can do my best Mark impression.
Turn left, Kevin.
Turn left.
Left more.
Left more.
Stop. Stop. What's that?
I don't know. I can't turn anymore. I was told to stop. Hey, look at that. I'm in focus. Thumbs up. We good? We're starting? Yeah? Perfect. Welcome, everybody. This is the Spokane .NET User Group. At least I hope that's why everybody is here. Tonight's talk is going to be Interfaces as Abstract Base Classes by Mark Michaelis. I was told I could lie all I wanted. So he is an
It makes me sound a lot better.
He is an avid skydiver, amazing gardener. I once heard that he saved a village in Peru. So he is actually a Microsoft Regional Director, author of the Essential C# book series, CEO of Intelitech. He knows a little bit, a few things about C#, I guess. So that is what we are going to hear about tonight. So is that, Mark, or we have intro slides?
We do.
We do.
Oh, am I going still?
You're done.
Sweet, I'm on a roll. We're gonna keep going. So we run a bunch of different user groups from the community around Spokane. So this is the .NET one. There's also a DevOps meetup and a Python meetup for people who are interested. Tonight's meetup is sponsored by Intelitech, which is where we are, or if you're online on Intelitech's YouTube, hi, subscribe button. We are always looking to hire good people, so if people are interested, you can find information at intelitech.com.jobs. It's not completely being covered up by my face down there at the bottom, so somewhere about there. So for the .NET User Group, it's always the second Tuesday of every month. Next month's meetup is going to be MS Build Beyond Building by me. So if I haven't scared you off yet, come and hear about that. It's going to be a little bit of, most of us use MS Build every day when we're compiling our stuff, but actually understanding how it works, working with the CS proj and what kind of extensibility is there is often sometimes that people shy away from, and it's not something to be scared of. It's something fun to play with. Or as I was told earlier, it's not something just used for calamities. So, for the Python user group, so next one is March 15th. Reese and Joseph, anything you want to add? Something exciting? Python in the cloud?
It's going to be great. Reese is going to talk a lot, and I'll pretend like I know what I'm talking about.
Perfect. I heard Reese is going to talk a lot, and Joseph will be amazing as always, or something thereabouts. Rough interpretation. Next DevOps one is March 22nd. It's going to be the third installment on Terraform. This one is going to be Phil/Jenny. I don't know exactly which one's doing which, but Phil and Jenny. March 22nd. A surprise third person. To be determined.
Kevin doesn't know yet.
I don't know about this surprise third person, and they didn't make the slide deck, so we're going to go with it. Also, more information on Intelitech. You can follow us on various channels, Facebook, Twitter, YouTube. For those of you watching online, you've already found one of them. Congratulations. There's the links for the others. And this is the part where I introduce Mark like I did at the beginning. So repeat everything I said at the beginning, and we'll go from there. And that ends the slide deck. Have at it.
With sort of a discussion, I'm going to need some help with people that are online. I would like to hear you guys. Similarities between interfaces and classes. Oops. Great. What else? All what? All members used to, in other words, used to be. Additionally, all members on an. Great. What else? There's a whole bunch of stuff. What? Yeah, great. Great, what else? Kevin, is this big enough? Can you guys see that? Great. What else? Some characteristics. Somebody deriving from an abstract class can only derive from one abstract class. So when you derive from an abstract class, it uses up whereas whether you derive from interfaces, you can derive from many interfaces.
Abstract classes lend themselves to patterns like factory patterns or abstract base method patterns.
Great.
Thing where you implement, have a default implementation.
Yeah, so go ahead and end here, but this is what we're going to cover tonight. So we'll talk about, whoops.
Yep. Any better? These might be done.
We better? Oh. This is dependency injection. Dependency injection. Is used injection. Abstract classes can be, but they generally aren't in cases. Excuse me while I get undressed. Sorry, was that on my microphone?
I don't know why that mic is giving you crap, so we'll just put in a different one, and the problem will be...
For those online, my microphone's getting replaced. You're gonna get a new speaker.
Chin down?
Chin down?
Down.
You're
Down.
serious?
Yes, serious. I don't joke about chins.
Okay, other differences or similarities. We talk about this construct. Have any restrictions around polymorphism? Just for polymorphism. The audience is stumped. Can polymorphism? Should we ask the question of what is polymorphism? The interview question, what is polymorphism? And many forms is not the right answer. So yes, it turns out to do polymorphism, you can do that with both interfaces and with abstract classes. Both of them can be used so that you can most implementation with both interfaces and abstract classes. The is in the most derived class, so it's in the class that implements the abstract class or derives from the abstract class, or it's in the class that implements the interface. I just determine how we're talking about it. We generally say a class derives from an abstract class. That's the terminology we use to say a class derives from an abstract class. And say a class implements an interface. When you do a derivation relationship, derived from an abstract class, you have an is-a relationship. So for example, a hard drive is a type of storage, right? There's an is-a relationship. A hard drive is a type of storage. Whereas you could like a file logger can do an iLogging interface, or can implement an iLogging interface. Two is there's an class and a class relationship between an interface. We talk about implementing interfaces and deriving from classes, deriving from abstract classes. So it's just common terminology, so it's easier to talk about. Using them it becomes very difficult to say, well, the abstract classes interface, it doesn't implement it. But it turns out that an abstract classes defines a contract, so you could, if you use the language loosely, implement. Any other differences that are important for you guys, or that you're aware of? When would you use an interface versus an abstract class? Any particular cases where you choose to use an interface versus an abstract class?
Define contract.
So
You're going to give us.
So what Seth says, traditionally, we'll talk about traditionally interfaces are a way of defining only defining how it's done. I'm getting undressed again.
No, we're just trying to, you almost solved it. Try that.
How's that? Okay. So when you define an interface, you define just the contract with which the implementing classes need to do. When would you use an abstract class? Common functionality that the driving classes want to share amongst them, that would make sense. So another way to think about this is you have both an interface and an abstract class traditionally before implemented interfaces. So it's both an interface and an abstract example for the logging mechanism. Typically not, but you could. So here's where you might want to do it. Imagine that I have a configuration interface. I could go ahead and define iConfig, and I could say set item and get item on the interface for going ahead and setting a name value pair and retrieving a name value pair value, retrieving the value from a name value pair. So I would have set and get. I would just have the members that go ahead and do set, and have the members that does get. But it's possible that I could come up with some reasonable implementation, for example, and the display of this, for example, iterate all of the getters, or all of the get methods, and go ahead and display all the settings that are available in the configuration namespace. And possibly have a default implementation that I could implementation on my interface that is able to retrieve all the settings that are available on the iConfig interface. And to do that, I might go ahead and implement that on the abstract class so that everyone has access to it. So now that that method is available and everybody who wants to use it, they could use their one and only inheritance by deriving from the abstract class. And they could get a default implementation for listing all the configuration values. Am I making sense? Is this, are we staying abstract enough? So the idea is to define iConfiguration interface. On the iConfiguration interface, we could have a get, we could have a set for getting and setting a configuration setting, and we could have a list that goes ahead and displayed all the values, but we don't know what the list would do, so it's just empty. Somebody has to implement it. Then we could take and define a base abstract configuration that implements the iConfiguration interface, And we don't know how to do the set and get because we don't know what the storage mechanism is behind that, but we could do the list because we could, for example, go ahead and iterate through all the getters and retrieve all the items, and in theory, we could display a list of all the items that are available. Depends on how you implement this, a bunch of details in there, but there seems like there's a reasonable possibility of a default implementation. And then if I want to go and implement a file configuration or a registry configuration or a distribution configuration, I would derive from the abstract class, and I would get part of the implementation for me. I wouldn't have to go write that myself because I got it from the abstract class. And I would automatically get an implementation of the stuff in the interface. It would, I would be forced to go and implement that. So in C#8, which is quite a while ago now, it turns out that Microsoft added the ability to actually put implementations in interfaces. And one of the characteristics about that's not clear is what becomes difference, what then becomes a difference. If you can actually have an implementation in an interface, what becomes the difference between an interface and abstract class? So we're going to go ahead and look at some examples. I've gone ahead and created a simple project here. It's a test project, and in the test project, I've gone ahead and defined an iThing interface, and it has a method on it, public, sorry, we should call it method thing. We've gone ahead and defined one method on the interface called the thing method. So it's just one method, and it goes and does the thing method. And then we've gone and implemented the thing by implementing the iThing interface on our class. It's not an abstract class, just a regular class. And we've gone ahead and defined the thing method, and we've said, okay, you're going to return the name of the type, in this case it's thing, and then go ahead and return the name of the method you're calling, which is the thing method. Okay, so standard interface, nothing fancy here. We're literally just implementing the method in the interface. Make sense? Okay, so we started with a simple example. I then went ahead and put a test in here, and we make sure that we can actually go ahead and return, when we call thing method, it goes and returns thing, and thing method, and we get back the data associated with that, Control-T, and the test runs, and we're good. Okay, so let's go back into iThing this time, and let's go ahead and change that method to be public. And let's go ahead and call this a public thing method to differentiate it. And of course, you should never change interfaces in the real world, but since we're not in the real world, this is the virtual world here, we're going to go ahead and change interface, which means now I need to go and implement that interface. So I'm going to go back to my thing class, and I'll go ahead and implement this implementation. We'll do that, and we'll go ahead and take this here and put it in there. And we'll go ahead and change this to return a public thing method, and we'll go ahead and get that implementation out. And the thing we're seeing already that didn't exist, oops, we forgot to, the thing we're seeing already that didn't exist before is that we can now put access modifiers on the members inside an interface. And you'll note back, and originally we said, hey, it used to be that all members were automatically public, and that is now simply that all members are by default public, but they can be decorated with private or protected. And so we're going to change this and say all members, well, yeah, that's it. By default, and that means because they're public, if I go back to my test, I can go ahead and access that member, and we can go ahead and, this is a thing method. Okay, so first thing, we can go and define members as in an interface as being public. It's interesting and curious. We can also do things like this. We can actually put implementations on our methods. So here we have have a standard interface method. We don't need to be a public. We can say this is going to be an I thing, and it's going to go ahead and return the thing method interface. We don't need to decorate with that. So now we have a thing implemented. What's interesting now, I've changed in here. I can now go ahead and compile, and you'll notice that I've not changed thing to add that additional method, but it now compiles. So we are now actually modifying the interface, published, modify the interface without breaking everybody's code. Everybody's code now works. Okay? Now that alone is an intriguing option that was never available. The best example that I like is in C# 2.0, there didn't exist this thing. So link didn't exist, and it turns out that matters. In C# 3.0, there was clearly a desire, or even a beginning of, hey, what if I could go ahead and have a collection of objects, something that implements IEnumerable, and I could do a .where, or I could do a .select. This is an obvious thing you'd want to go do in a collections. You want to do a .where and a .select. But the C# team was limited. They couldn't add a .where or a .select because doing so would change the interface, and thereby everyone that implemented IEnumerator actually, everyone that implemented would then break and have to change their code before it compiled. So just the very name allowing a default implementation on an interface allows you to modify interfaces without that alone is a worthwhile thing to have as a feature language because it change interfaces in some way that I could never do before. Not surprisingly, we can decorate this with public. And we should actually go add a test for that one before. We're still not working? Oh.
It worked for about 5 minutes.
Is that better? So I'm going to go ahead and change this. We're going to go ahead and call public implementing method. And here we're going to go ahead and it's not exactly the name of iThing because the thing that we implemented on is iThing. We're going to go ahead and access this guy. Yeah, no, I understand. And you'll notice that I can't go ahead and access it on the thing anymore because I've only implemented in the base class. In the interface. And so this actually becomes iFit. And the method that we call is this guy. And furthermore, it's not actually available on the thing. I have to now go ahead and cast. Check to get it to be available. Make sense? So by default, when I go ahead and add a member, an implemented member on the interface, that member is now explicitly implemented in the derived class. So just to review, let's talk about an explicitly implemented member. We're going to go ahead and do thing message here. I'll do thing message 2.
thing method. We'll go back to the thing over here, and we'll go ahead and implement that member. And here, we're actually going to default it with prefix with thing. Thing explicit method. Right, they're not working. Hold on.
You don't have the public modifier on the interface. Is that
No. Nope, that's not it. Thing explicit method. Yeah, this is very template. Oh, it's because I had public. Sorry. So the problem was, let me put the code back to get see what happened. I decorated as public, but because it's on the icing interface, you don't need to do that. Oops, I thought that was done different. Let's try it again. This is what I had. I just wasn't returning the thing. That was it. Okay, so now but I don't think I can decorate this as public. Yeah. So when you're implementing an interface explicitly, you can't decorate it as public because it's automatically public because it's on from the interface, and it wouldn't make sense to go and implement something without making it public to do that. You would do the whole point in implementing the contract. So implementing an interface member explicitly, you cannot decorate it as public or not with an access modifier. You simply have to go ahead and implement it like that. Aries. That's a good question. I don't need this guy. So the question was, even though you're doing this, can you still access it as public? So the very characteristic of it being at that level. What do you call it? If we go ahead and take this name here and go back to here, and we're going to implement this test initialize. So this doesn't work. We have to cast it first in order to access it. And then we can go access the, oh, that's the wrong member. Regardless, it's true. So you'll notice without the cast, the member is not available. And it's not, you cannot decorate it and say that it's what's wrong? You cannot, on the thing, you cannot decorate it to say that it's public because you've already specified that it's explicitly implemented members. All explicitly implemented members on the class are automatically public, not by default. They are automatically and only public. Therefore, you can't specify an access modifier. So when you want to go ahead and call an explicitly implemented member in the test, you'll notice that I have to go ahead and cast in order to access that member. The very nature of having the opportunity to implement things explicitly is something that allows the member not to appear unless you cast to the interface in order to use it. That is true before we had default implementations of interfaces. So the idea of having explicitly implemented class versus explicitly implemented interface member is that in order to access the member, you have to cast it to the interface in order to access it. Let's just make sure here we've got this on an interface. It's explicitly implemented on the thing. And we need to go check the implementation. So on thing, we're going to go ahead and say thing method. It's going to call iThing.thing. No, we're doing, sorry, this guy. It's going to call, it's on thing, and it's going to call iThing.whatever. You'll notice that inside the thing class, we cannot access the thing explicit method because it is not defined here. It's only defined on the interface. So in order to get that name, we need to go ahead and cast it to the interface, or in this case, just use it since we're just using name of iThing dot. So in this case, now we can access that member because we have to have an iThing in order to access that member.
Does this mean interfaces are not concrete types?
So the question was, does this mean interfaces are now concrete types? And I think the answer is it depends what you mean by a concrete type. In other words, it is a type. There's no doubt about that. You can do an is-a relationship in interface. So I think I'm unsure of how to answer the question because I'm unsure of how to answer the question is a concrete type. That's it. Okay, that's a different question. Can you now do new on an interface? And the answer is absolutely not. Absolutely not. Because of one really important characteristic that is still totally differentiates an abstract class from an interface, and I'm not going to say what it is yet. But if you guys mention it, then we'll bring it up and talk about it then. Okay? So, we're clear on the fact that you can have explicitly implemented members on interfaces. Now the question back to you is, why did the C# team allow the idea of an explicitly implemented member on an interface? Why was that feature added to the language? Which, my understanding, it's one of the few languages that had this characteristic, at least when it first came out. I haven't encountered other languages that had explicitly implemented members, interface members. Why? Why is it possible to explicitly implement an interface member?
You have two different interfaces that have the same method.
Yeah, so exactly right. One of the main reasons is since I can implement multiple interfaces on my class, there is the possibility that I could have an ambiguity because both of them have the same member defined. So if I was deriving from iThing and iThing1 and iThing2, and they both had a method called method, and then I implemented both those interfaces, if I didn't have a way to do it explicitly, it wouldn't be clear which one I was implementing. And I may want to do the implementations differently. Right? It's not assumed just because I implement iThing1 and iThing2 that method has the same meaning. They could be completely different meanings. So one of the reasons why the idea that you'd explicitly implement an interface member is so that you can disambiguate when you implement two interfaces that have the same member defined with the same signature. But there's another reason. What would that be? It turns out that interfaces have classes have a can-do relationship with an interface. They can do something. But sometimes there's nobody who's going to call the method on the interface except for the library that's interacting with the thing that implements the interface. So for example, you can imagine that I would have something like a logger. And the logger requires you to pass it an iLogging interface. But nothing else needs the iLogging interface, and nothing else needs to use it. So on the logging interface, there's a log method. But the only time I'd ever use the log method is inside the library that looks for the iLogger interface. And if I go ahead and implement it implicitly, not explicitly, that would mean every single time I do a dot operation on something that implements iLogger, I would see a log method, and it would have no meaning to me or usefulness whatsoever, because it's only used by the library that does the logging. So in general, it's frequently the case that when you implement an interface, it's not a core characteristic of the object that you implemented. Hypothetical example. Imagine that you're trying to do something related to memory, and you want to have an interface that can actually go ahead and dump out the memory. You would then have an interface, for example, called memory logger or something like that, and then you'd have a member on there for dump, to dump out the memory. Okay, and then you implemented a person class and you wanted to dump out the memory on the person class. You can see it might be a little bit problematic if I went to instantiate a person and did person.dump. What exactly would that mean? Right? It has some some creative implications of this idea that I could do person.dump. But it wouldn't make sense for me to have a member in person.dump. I would just implement it explicitly. So in general, nobody would go ahead and do person.dump because they wouldn't see the dump member because it's implemented explicitly. And so now, infrequently, when you go ahead and have interface members that you're implementing, you would implement it explicitly because they're not inherent characteristic of what the object is that it's actually using. If you have an interface that is representing an is-a type relationship, such as an I-person interface and then a person, you would imagine that you would never implement the interface the members explicitly, because you would always want them to be available. If I have an I-person interface and I'm implementing a person class, it seems reasonable that I would always have a name property, and I wouldn't have to cast to I-person in order to access name. So if there's conceptually an is-a relationship between your interface, just the same way as you have a person has an is-a relationship to an I-person, it seems reasonable that all the members would be done implicitly. If you only have a can-do relationship, where you just want to make sure you have the capability of doing something, but it's not inherent to what you are, it's not inherent that a person has a dump method, it's not inherent that a car has a dump method, it's not inherent that a memory stream has a dump method. So what does it mean to have dump on those types that you're implementing, like memory stream? It doesn't mean anything. I don't understand why it has this method there. In which case you'd implement explicitly, then when you do the dot operation, you don't see dump, and you're not confused by this member that doesn't make any sense out of context. I think part of good API design is to be very conscious of the fact that you can implement things explicitly, and generally look for the cases of, oh, I should implement this explicitly. And I would almost say, this is probably pushing the truth, but I would almost say by default, I would implement members of interfaces explicitly. Unless you're the one always using, like if you're creating a mock class or a test double, then it doesn't make sense for you to do it explicitly because you're calling member all the time. And the syntax for casting is nasty, right? This syntax here, this is a nasty syntax to go ahead and do a cast in order to do a dot operator. And so if you don't have to do it all the time, then by all means go ahead and implement it implicitly. But I would lean towards saying, at a minimum, every single interface member that you implement, you should consider, should I do so explicitly rather than implicitly? I think that's a reasonable guide. Have you considered whether this should be done explicitly or implicitly? Okay. None of that, it turns out, has anything to do with default implemented interfaces, but it's an important characteristic of understanding what can be done with interfaces. So the point being here, when we go ahead and implement this method, thing explicit method, there's nothing in the interface that can force a deriving class to implement explicitly or implement implicitly. That's only the driving class's choice. In this case, we chose in the driving class to implement it explicitly, so we prefix it with the interface name. But there's nothing in the interface that forces me to do that. Joseph.
If you explicitly implement it, it's automatically public.
I said earlier, if you implicitly implement something, it is always public, However, you cannot access it without casting. So I can't, in this case, I cannot go ahead and declare this as public, because doing so, it says, wait, you're doing an explicit implementation of an interface. If you explicitly implementation a member of an interface, it has to, by definition, be public.
What happens if you also mentioned that now in C# you can define an interface method to be private or protected?
Okay, so now the example is, if we go ahead and, oh, okay, that's a different question than I thought you were asking. So I mentioned you can have access modifiers on your interface members. Let's look at a couple examples. First of all, let's go ahead and do one that's private. We can go ahead and have a private thing implemented method. And if it's private, you'll notice that in here, I'm not even sure why I have that one. You'll notice that the private one is not even available. Because it's private, as you would expect, it is only available to the interface. Because it's private, as you would expect, it is only available to the interface. So then the question is, why do you even allow it? I want to make this one point further. So we can't implement it explicitly. We could go and implement it privately. However, doing so has no relationship This has no relationship to the interface at all, and in fact, it's not available. We would have to go ahead and just write this here like this, because it's on the interface member, not the on the class member, not the interface. Make sense? The next question that is being asked is, or suggested is, well, you'd want to do this because you want to refactor. My words, not Seth's. But the idea is, well, I could go ahead and do this so that in this method, I might, for example, do a and then instead of this, I could go ahead and call to return that method because I wanted to implement some kind of refactoring. So we can see if we're going to allow default implementations of members, it is presumably reasonable that we'd also allow you to have private members because it would be kind of restrictive if we said, oh no, you can't do any complex methods. It has to be really simple. The idea that we'd have two methods once we return something similar and we want to refactor that code into another method, that would be, it would be unfortunate if we couldn't have private methods that allow some kind of refactoring like that. Reese. Oh, so now we're getting to some interesting space. Could we go ahead and decorate this as protected? Because the method here makes sense. What if we went ahead and change it to be protected? And what would that mean? Just want to make sure we're going to end up with what we want in the end, and I think this will work fine. So the answer is yes. Of course, if you can go and implement as private, wouldn't you want the possibility to go and implement it as protected as well? And so now we've gone ahead and marked it as protected. Let's go ahead inside our thing class. Let's go ahead and override that protected method. Sorry. Okay, so in here, we're going to go ahead and put that same method. And we'll go ahead and return name of thing. And we now have a protected member that we're not calling it. We have now defined a protected member. What do you guys notice? We didn't mark it as override. And if you don't in C# mark something an override, you should get a warning. But we're not seeing a warning. Okay? We're not seeing a warning here. So the...
So I didn't notice, like, if you comment that out, does the class complain if you're not implementing the interface?
No. Because it's got an because it's got a default implementation, there's no reason to complain.
So is that actually even overriding it? Or is that just like, here's the one for my class?
Yeah, so the question is, how do we prove this? So the question was, is it actually overriding it, or is it actually a different instance altogether? The question is, how do we prove one way or the other? This is nasty. Okay, so we got to go ahead and do a public string get type name. Let's do this as protected. And this is get type name, and it's going to go ahead and return this guy. Make sense?
Well, now that has a name, so that's,
Wait, what is a totally different name? No, I'm going to change it both.
Oh.
Thank you.
I like it. So, right.
Okay, so the best way to show this is to push F12.
Can you still explicitly call it?
Can you still explicitly call it?
Ask it just to
Yes. That's the whole thing. Hold on, we got a problem here. Why is that one? Oh, because I got basic. Something's not working. Protected. This is the thing I was going to show at the very end, just so you know, because it's nasty getting this to work. Protected. Oh, I think I need to do an I thing this. Dot. Cannot access protected member via qualifier type I thing. The qualifier type must be thing. I don't believe that. How the heck do you call this method? This is the very final thing I wanted to show you guys. And I can't remember how to do it.
get with your tasks, but it can do control dot if you suggest you have to fix it. Can you test out if they're into a thing?
Yeah, but it's not going to help me. Okay, so just what I would go through the problem again. We have a protected member on the interface, and we're trying to call the protected member. And what would be the point of having a protected member if you couldn't call it? I can't remember the
I
solution.
would think it'd make more sense if you run interfaces.
That may be the answer. Let's go ahead and do that. So I'm going to go ahead and in this same class, in the same file, I'm going to go ahead and create an interface I thing derived. And then I'm going to go ahead and put a member in here, string I. There we go. Thank you. Couldn't think of how to do that. Which may mean we could just call it actually. So the moral of the story is you can have protected members in interfaces, but they only go forward in inheritance relationships between interfaces. What becomes really interesting is how do you call this method? So you would have to go ahead and cast it, or you have to implement iThing derived to go ahead and call the protected get type name to get back data. And in fact, it would be what you would expect here is that we would override this in our for ours because of the fact that we don't want it to be iThing, we want it to be iDerived thing, and in this case, we want it to be overload. Nope, you can't. I think it says it has to be new. Hide base member. What was that? It just puts a new in there. But it's not supporting override. Oh. No, the problem is this. Oh, the problem is I've already got it implemented. Dang it. Try one more time. Okay, it doesn't support it. The only one that's available. Not giving me any overrides. Okay, there's no override. You can decorate it as new, but you can't decorate it as override. So you can put a new, that's not going to work. You can put new, but you can't decorate as override. Okay, next question. What does new mean? This is not new, so this is not new. This was true in C# 1.0. What does new mean? That's a true statement, but out of context. So the statement made was it allocates memory, which is absolutely true, but that's in a totally different use of the keyword new. The answer is true, but this is when you use new as a modifier on a member, it has nothing to do with memory.
Does it make it like a new method or a different method? And so like you can explicitly call it from the I thing derived and also differently from I thing.
Yeah, so Zach has got it almost exactly right. Well, actually, it's exactly right. So the whole idea here is when you mark something as new, you're saying ignore the fact that there's an implementation in the base class and use the implementation on the iDerived thing class if you are an instance of iDerived thing. If you cast to, in this case, iThing, it will use the implementation on iThing. If you cast to an iThing derived, it'll use the implementation on iThing derived, which is different than override. If you do override and you're inside iThing derived, you will use the iThing derived implementation. If you do override and you cast to an iThing, you will also use the iThing derived implementation. In other words, when you decorate a member as virtual, you're saying use whatever is the most overridden, the most derived implementation of this member.
So is your issue you didn't declare virtual?
It might have been actually. I'm just wondering that myself. Oh, let's try it.
You didn't say you were allowed to override? Still the same.
Still saying no. It's only giving me new implementation. One question I want to go back to the new. So why was the facility to support new as a modifier on a member allowed? Why was that important? And as a similar question, why is the default to have new? So when you go ahead and do it like this, where there is no new keyword, it's going to inject the new keyword for you and assume that by default, if you don't specify, you meant new. Back to my question. Why is new as a modifier added to the language? Help with what? To help with name collisions. Maybe it's not the way I would have put it. Let's imagine this scenario. Let's imagine that I implement a method on thing, okay? And I implement the I thing. Okay, let me say it again. I implement a a do something method on thing. I implement do something method on iThing. And I implement the iThing interface. Okay? At that point, if you go ahead and call the do something member, it will obviously call the do something member on thing. Correct? Now imagine that I change my interface, something you should ever do, but I change my interface and I go, oh, that do something method, that's really clever. Let's, in fact, it's so clever, we should put on an iThing. And I go add the method to iThing. Or no, actually, abstract class. I go add it to an abstract class. So, sorry, I was missing one level. There's multiple levels of complexity. We have a base class called base thing. We have a class called thing. Interface is irrelevant at this point. So in thing, we implemented do something method. With me? I then go, oh, that's brilliant. We should put that in the base class so that everyone can take advantage of it. So we go ahead and add the do something to the base class. And we mark it as virtual. but the base class thing is implemented in an entirely different library than your implementation of thing. Like, let's imagine there were two different assemblies. There are two different assemblies. If I go ahead and add the do something method to the base class abstract class thing, when your code executes and it uses my library, should it use the new one that was added to the base class, or should it use the existing one that was already defined that I did before you even added the do something member? You want it to use the first one.
Isn't it going to use?
It is going to use the first one.
It's the nearest.
It is going to use the one because it's the nearest one. That is also true. But if you are accessing it through polymorphism, you could prevent it from actually going down the stack. You can actually get it to go and do the first one because you didn't mark it as virtual. So if you go in the base, with the base thing, if I don't mark it as virtual, it'll go ahead and call that one, except for the fact that I marked it as new on my item. So the whole idea, I want to be very clear about how it's hard to be clear on this thing, but what I'm trying to do is make sure that behavior doesn't change when I add a member to base class. The behavior must stay the same. And in order to get the behavior to stay the same, it defaults to hiding the base member and using the most derived implementation, even if the base member was not marked as virtual. Even if the base member is not marked as virtual, it still goes and uses the most derived implementation because it doesn't want to change the behavior without you having to make code changes. If you don't compile your code, it will call the most derived member. If you recompile your code, it would still call the most derived member, but it will give you a warning, which is what we're seeing here, that says, hey, you're hiding an inherited member. Now make an explicit choice. Do you want to use the old implementation you had, or do you want to go ahead and use the new implementation that's being added? Make a choice. Go ahead and choose to do override, or go ahead and choose to do new. Whichever one you want is fine. Except for this is giving us a choice. It says, this is, so Seth is exactly right. In this particular case, the only option in a interface that's implementing a thing is to go ahead and mark it as hide. You cannot do override on those members that are marked as protected. In implemented members marked as protected.
For the new modifier, you have a subsequent interface that is new on the same method as the base method. The lowest implementation in the hierarchy.
So the question was, if you have an inheritance of interfaces and the lowest implementation, you use new to override the base implementation. Did I say that correctly?
Repeat that.
we have two interfaces, one deriving from the other. We go ahead and add the same member in the deriving interface, and we decorate it as new. And in doing that, which one is going to get called? I don't know what the question was, because I was trying to restate the scenario.
Leave that as the new modifier, you have subsequent interfaces that you can do on the same method as the base method. The lowest implementation in the hierarchy.
Yeah, and the answer is yes, the lowest implementation in the hierarchy will be used. Can they hear what you just said, or would I need to repeat your question? Stink. Can I read the question? Okay. If you had the same member implemented on two interfaces where one implements the base interface, the most derived interface implements the parent interface, will the most derived implementation get invoked? And the answer is yes, because it's going to go ahead and be new. So the most derived implementation is going to get invoked. Okay. There's a couple, I think we're going to come back to this, but I want to make sure we do a couple things before that. So there's a few things we haven't tried on interfaces that we can try on abstract classes. What are they? Okay. what have we got on abstract classes and interfaces? What other things can you do with abstract classes that you'd like to go through with interfaces? So the question was, hey, we can do multiple inheritance. You can still do multiple inheritance on interfaces, and you still can't do multiple inheritance on abstract classes. That is true. I'll just state that as a fact. So one thing that we've not, there's no change here. Interfaces could always allow for multiple inheritance, and they can still always allow for multiple inheritance. Abstract classes could never allow for multiple inheritance, and they still can't allow for multiple inheritance. What else? Things you can do in abstract classes that you might want to do in interfaces, but you couldn't. But maybe you could now.
Call a derived implementation inside of the base class, like abstract function. We call the abstract function, and it calls the code from the
So the statement from the interface?
right from the interface.
So the interface can't call the implementing class as member unless it has defined the member itself, because it doesn't know it exists.
So like in an abstract base class, you can mark a function as abstract inside of the abstract base class, call that, and it's going to call the implementation from the
Yes.
derived.
So can you have a member in the interface that's not implemented that is called from the interface? That's essentially the similar scenario, right? And the answer is yes. So could I go ahead and from here we have a thing explicitly method or just a thing method? We can in here go ahead and invoke even though it's not implemented. That's totally fine, totally doable. You would expect that to work. What are things you can do in abstract classes that you couldn't traditionally do inside interfaces? Yeah, but we've shown that that's possible. A default constructor, yeah. So it turns out you cannot put constructors inside interfaces. That's a good example. Interfaces cannot contain instance constructors. You cannot construct them, default or not. You can't have constructors inside interfaces. Good, that's a good one. What else?
I want to try something from right here, but private field for private property. No.
So can you,
C# work.
yeah. So let's start with the first question is, can you have properties in interfaces? Sure. And it is not marked with an access modifier. That is by default what? Public. Can you mark it as public? Yes. Can you mark it as private? No. Oh. How about protected? Yes. Wait, what? What?
Derived interface.
So there's a comment about deriving or not deriving, but let's be very clear. I can have access modifiers on my property. It does allow me to do protected. It does allow me to do public. It does allow me to remove the access modifier entirely, but it does not allow me to do private. What is going on?
Because you wouldn't be able to use that. You would be able to use name.
Well, why couldn't I do it from inside here?
Because you're not gonna be able to cast it.
But what do you mean? I can inside here I could call name. I mean,
couldn't outside it. Just because you can do it inside doesn't mean.
Yeah, but so what?
It's the whole point, right?
Huh?
It's the whole point of private. It's only inside.
Okay. Prior to implemented interfaces, could you have a property on an interface? Yes, absolutely. We could have the name property on the interface, and we could have no access modifier, correct? Absolutely true. When I go ahead and define a property on an interface without any access modifier prior to implemented interfaces, what does that mean? What's the contract? On the implementing interface. So now on thing, I would have to have a property for name. Okay? And in order to implement the property, what would happen? I'd have to go to thing. I'd have to implement the property called name. What is different? Ignore the warning. What is different about what happens when I do this on the class compared to what happens when I do this on the interface? There's a very, very important difference. This is called an automatically implemented property. What does that mean? It creates a field in the background, and the setter sets the field, and the getter retrieves the data from the field. And the field is what? It's private. It's not even accessible. It's as a mangled name. You can't get access to it. Okay? When I go ahead and define a protected member in the interface, it allows me to do it because the deriving interface could also implement it. Or the deriving, well, we can make it public. We can mark it public. Doesn't matter. What is the difference when I go ahead and mark it as private? What is the implementation? Sorry, Kevin, you have to wait. Remember, what was the implementation of an automatically implemented property? It has to have a generated backing field. And it turns out that you cannot have storage inside interfaces. It says namespace. Why the heck does it say namespace?
Yeah. It's tight. Oh.
Interfaces cannot contain instance fields. You cannot have data in the interface. Now, when we define a property interface, we are not defining data. We're telling the derived classes to support the ability to contain data. But there's only supporting that ability through a getter and a setter method. It is not actually containing the data. So the distinct difference of why you can't have a private property on an interface is because it would have to have a private field, and you can't have fields in interfaces. However, we could do protected because the deriving class could implement it, and we could do public because the deriving class could implement it. We could put the storage somewhere else. We just can't put storage of fields on interfaces, and that is a huge distinction between abstract classes, which can have fields, and interfaces, which can't have fields. However, that doesn't mean we can't represent that we should have storage. We just can't have the storage. Question from the audience, from the online. The question was, is internal a valid modifier on an interface? And the answer is yes. By the way, You should never answer questions you don't know the answer to. You should never answer the question before you've checked, right? I, of course, knew the answers, so no. So the answer is absolutely you can have internal on an interface because there's a reason related to refactoring that you might want to support that capability. So in fact, the way I would generally think about what interfaces can do and the fact that they can have access modified as an implementation is once you've got over the hoop of understanding that there is a reason to have a default implemented member on the interface, everything is possible in order to support refactoring, except storage. And internal, it's certainly a valid way. You may want to do something related to refactoring that you put in for, you want to decorate as internal. So internal is totally supported. Okay? The only case that's not supported is something that forces storage. That's not supported. Which brings up another example that nobody has mentioned yet of a modifier you can have in a member that we haven't used at interfaces yet, but you can do inside implemented members. What is that? It's another modifier. So we've looked at new, we've looked at override, we've looked at public, we've looked at private, we've looked at protected, we've looked at internal. We're still missing static. Can you have static data inside an interface? And the answer, of course, is yes, because where else? Static. Do some what did I do? You can now go ahead, because obviously you will go ahead and refactor methods, and it might give you a warning that you're not accessing any member inside the class. And so it's going to say you should probably do this as static. Because the most typical example for refactoring is likely to be a static refactoring, to go ahead and put all the logic you have related to method inside the static because you're not accessing any other member of the class. So static is totally supported. And in fact, you can go and have static storage on your interface because it's not an instance. So of course you can have storage associated with the type, not the instance. It's not called. Oh, it's actually nullability. Huh. I haven't initialized it. Okay, we've got 10 minutes before we're done. And here's the $50,000 question. When do we use abstract classes and when do we use interfaces? So the distinction in the past was clear. We use interfaces to define a can-do relationship, mostly in support of polymorphism. However, sometimes it is possible to come up with a default implementation, in which case we create an abstract class that implements the interfaces and the members that we can come up with default implementations for. So we can make the implementer of the interface find an easier way to do it because of the fact that they've got some of the members that implement it, even though others were not possible. Okay, now we get into this interface world. And in this interface world, we're in a scenario where we can do everything I just described. We can have default implemented interface members. We can have default implemented members on the interface to save the work of somebody having to do all of the members there, because we can come up with some reasonable default that you could do. Except storage. We cannot implement storage. So the question still stands. When do we want to use interfaces versus when do we want to use abstract classes? let's go through a scenario. If you can define an interface and it is possible to give a default implementation, should you? If you can define an interface and you can come up with a somewhat reasonable implementation for a member, should you provide it? Let's go back to the example I gave at the beginning, and I sort of waved my hands, and I was hoping nobody was going to catch me. But I talked about an I configuration interface, and I said it has a setter and a getter. Okay, that seems like a wonderful thing as an interface. And I waved my arms and said, we can imagine we were going to have the list that would go ahead and retrieve all the members. Remember, it said list all the members so you can get the name value pairs coming out. What would be a default implementation of a setter on an interface, of a set method on an interface? What would be the default implementation? It would have to set storage. It would have to do something. There's no reasonable implementation. I mean, I can come up with implementations like accessing something static or something like that, but that's ridiculous, right? So there's no reasonable implementation for the setter. Because I don't know what the default implementation. I may be storing in a file, maybe storing in a stream, I may be storing in a JSON, I may be storing XML. I mean, who knows where I'm going to be storing? Doesn't matter. I mean, it's unknown. So there's no default implementation. So I could have a get value that takes a name parameter, but I can't come up with a default implementation that doesn't make any sense. I could also have a I did set first, right? I could do get. Where would it get the data from? On my configuration interface, there is no way for me to come up with what the default implementation on the getter would be for iConfiguration. It doesn't make any sense.
Well, I think your default implementations would have to make sense with the other parts of your interface. Like you can get everything you need from your other methods. But it seems like that's where it's reasonable to do a default.
Yeah, so if you can come up with some meaning. So let's carry this example a bit further. I talked about a list member, like list on this configuration. So I waved my hand. It was beautiful the way I waved my arms. Nobody sort of called me on this, which I really appreciated. Thank you. I appreciate you guys doing that. I said list, and it would go ahead and call the getter. But what would the name be? How would it call the getter and provide a name? Because you got to go ahead and return them all. Yeah, right. So it turns out that we would have to go do something more impressive, like actually implement an iterator or something like that on the keys. So we could have sort of something like a keys, and we go ahead and return all the keys. And if you did that, you could literally provide keys. Now keys isn't implemented because we don't know where it's storing, but I could iterate over keys and then return all the values. Like that would be a reasonable implementation. Probably be the only implementation that you even need. That would be a reasonable thing to do. But all of the data is abstracted into the classes that actually implement the interface. There's no actual storage access within the interface itself. So I would argue that, yes, it makes perfect sense to have interfaces that have default members if you have a reasonable default implementation, because you're saving the work on somebody that's deriving from you from actually doing that. However, there's a caveat. Normally, when we go and implement interfaces, we go ahead and do a dot period and have it generated. And we get filled in with lots of not implemented members. I guess you follow what I'm saying? It says not implemented, not implemented members. If you provided a default implementation, it wouldn't show up. And so now the presumption is not only that you provided a default implementation, but it's good enough that nobody has to even think about the fact that they haven't gone ahead and overridden it. Because you've implied that your default implementation is good enough in the vast majority of scenarios, unless you're doing something special, in which case you should override. The default is good enough. In which case now we want to be really wary about, okay, does this really make sense for us to have a default? Is it really a default possibility? Or do we really want to force the person to think about it? And if we want to force the person to think about it, then by all means, we should have something that they have to override or implement. If it's Does that make sense? So my summary is this. you should go ahead and define interfaces in the traditional fashion as you always have. That's your default. If there is a member for which you can come up with a reasonable implementation without somebody having to look at how it works or examine it, then by all means go ahead and provide a default implementation. But I think it's relatively rare. I think it's relatively rare. The advantage of doing that is you don't force up, period, done. Just like when we went ahead and create abstract classes with default implementations for our interfaces to reduce the burden of having to do an interface implementation, we can now go put that default implementation inside the interface and remove the additional injection of the abstract class. Okay, as long as no storage is required. As long as you can do without the storage, that's a reasonable thing to do. So I'm okay if you don't need storage to use an interface and have a default implementation if you've got a reasonable implementation for a member that needs to be defaulted. And doing that in all cases, you would use abstract classes unless you need storage. As the advantage being that you support multiple inheritance and you're not using up the one and only inheritance model that somebody has. If you have to have storage, you have to use an abstract class. If you have to have storage, you have to use an abstract class. That's the only option available to you. But remember, this concept of protected properties allows you to do virtual implementation so that the most derived can then have it. So there is a way to simulate the idea that I could have storage if something implemented it. You could start to support the concepts. Okay? Use interfaces the way you traditionally use interfaces. Use abstract classes the way you traditionally use abstract classes. If you can come up with a reasonable implementation that you don't want somebody to have to look at, do a default implementation on the interface. If you have to have storage, go ahead and use abstract classes. And that should cover all the scenarios that we've discussed.
You do this big long talk and answer the question to the talk. I
I don't know if you would have got quite as much out if I just summarized with those things, because there's a whole bunch of explanation that goes in between them. I didn't get around to this scenario of how do you call the protected member in the base class. This is the one thing I didn't do.
But is that because it's not an ISA, so it doesn't have access to protect?
This is inside. Yeah, this is inside the implement class. Thanks. Yeah. Okay. Fine. This was available in the deriving interface. You can go ahead and access it. Let's go. But I still don't think you can call base. Yeah, there's no base.
Right. Because it's not deriving something, it's implementing something. Because base is the derived. Base is typically the derived class, not the interface. If you never call base on it.
Yeah, but this is I'm in the derived class here. I'm in the derived interface here.
But is it derived or is it just implementing, I think? Syntax is ambiguous. It's just full on, I think. Because the relationship between I think derived and I think is a or has a.
You can't. I can't remember how to do this. So let me. I know this is really hairy, and it's like it takes a long time to figure out how to do it. But it's something like this, and I'm waving my hands intentionally here. But it's something like this that you can. The interface itself can go ahead and call this member, Man, I can't figure out how to get access to this guy. So let's do an I thing dot. Still not there. Oh, where? Here? This is just because I need members. That's not available. I can't remember how to access this protected member. As an exercise for the audience. I did. This is explicitly.
But like, I think that,
But that would be stat if it was static.
no, I mean, type of string, I think dot second.
Sorry, tell me what's type.
So back up to string.
So, yeah,
Yeah, I think
that is, but you remove it at the end of your.
So I guess what Joseph is saying, that does seem like now I have that. I have access. I've implemented that member explicitly, and I could go put something in here. Return. Whoops. Sorry. Just. Still can't see it. Let's just return this. What's interesting about doing this is now in my thing class. Let's remove that guy. You'll notice that it's not required that I implement that member because there's a default implementation. Wrong one. I can't think of why you would do this. Okay, there we go. Oh, those are the members that I added. Oh, it's name. Sorry. I added name afterwards. So I can't come up with a reason why. I can't remember. Sorry. Question. Why can interfaces not have storage? So interfaces never. So look, think about it this way. You have a class with a whole bunch of members. And when you implement an interface, you are saying, take these select members, we'll pretend the interface is at the top. take those members and just expose this piece, just expose that piece of data. And so it looks like the interface. It looks like the interface. But from a memory perspective, the class is still the same. The instance is still the same. So I do new thing, and it instantiates my class. I've now got memory. Okay. When I cast to the interface, I'm basically just putting a filter over this and saying, just look at the stuff about that interface, but it's laid over the memory and say, just look at it, it's like this. Okay, but I can't lay it over here and go consume additional memory because the instance, when I do a memory allocation, I just have this block of memory. I don't have additional blocks of memory based on the interface. The interface just says, look at this memory as though this is all I'm capable of doing. That's what an interface says, you know, in terms of the way it's working underneath the covers. It says, look at this type as these are the only things that I'm capable of doing. It still has all the memory that's associated with instantiating. Does that make sense? I can imagine a scenario where, oh, if we provide the interface and as memory, that would essentially increase the size of the storage. I mean, you can imagine an implementation in the runtime that this was possible, but that's clearly not the intent when it originally started. The interface is basically, make me look like I can do these things. Don't do anything else than that. Just make me look like I can do these capabilities. And there's no idea that not only do we instantiate the class, but we also instantiate the members that the interface has that are placed in the field. That would significantly change the implementation around what happens when interfaces are there. So the reason it's not there is, first of all, it wasn't thought of as a concept you need to do. Number two, adding this would be nasty. And number three, it's questionable whether we need it. I think it's bad enough that we have got default implemented members. But really the only scenario, so here's the scenario I would say, you may want to do this because you want multiple inheritance. Now the question I'm going to ask is, give me a real world scenario where you need multiple inheritance. And don't go say military vehicles and, like, we always come up with, like, like, as an author of a book that's trying to come up with examples of multiple inheritance that are actually valid for everybody, it's really hard, right? It turns out that we think this multiple inheritance is a really cool thing, but if I asked you to come up with real world scenarios where you need multiple inheritance, you'd have a really hard time doing it. And you've probably never been programming going, oh man, I'd really like multiple inheritance. That's not true. That's not fair. There are cases where you want to do this, and there are ways that we implement the pattern. But it's a pretty rare scenario to say, I really need multiple inheritance. The reason why this is a really big deal when .NET came out is because the precursor to .NET was ATL, active template libraries, which was essentially the same thing without a runtime, all done in usually C++. Actually, ATL was still all C++. And it was entirely, like the entire platform, literally, was built on multiple inheritance. You would have 7, 8, 9 different things you're inheriting from in order to support this, because C++ supports multiple inheritance. So when you defined another capability, you just added another thing you inherited from. And so it was really difficult for people to switch from ATL into .NET because they're like, oh my goodness, I did everything with multiple inheritance now. So it was a big controversy when .NET first came out. I bet you within the first year, everyone forgot. Well, number one, because ATL is really, really hard, right? Like really hard. And number two, they realized they just didn't need it. So the multiple inheritance is sort of a setup. It's not really that important. Raise hands. How many times you got, like, I really want multiple inheritance? Okay, so for those in the online, there's about 500 people in the room and nobody raised their hand. Any other questions before we end? Reese.
You make me wonder, why did they go to implement this plan? It seems like basically the guidance keep doing.
So the question was, why go ahead and provide default implementation to members? And it turns out there's a lot of things happening in languages because there are other languages, and people are curious about what your language supports and what my language supports. And it turns out Java added this capability in relatively recent history, right? Within 1 or 2 or 3 years before C# did. And so it wasn't that hard to implement. It was something that is attractive to people coming from the Java space. Why not go in and support it? And it's a real world scenario. Like, I mean, there are valid scenarios where you can provide a default implementation to save somebody else having to go and write it. And you don't expect people to implement interfaces to also have abstract classes. So I think there's I just think there's some validity to going and doing it. I don't actually think it's just because another language did, but you can see that it wasn't that hard to add. And by adding it, we are able to reduce the amount of code you have because the people implementing the interface have to do less. So I think there's a legitimate argument for why to do that. But I can tell you, in every single talk I did before this came out, I would say to people, what features do you want added to the language? And nobody ever, and I've done this talk in like Finland, I've done this talk in a lot of places. Nobody ever said, man, I would really like to have default implementations in interfaces. Like nobody said that to me. But clearly somebody told the C# language, it looked nice, it was attractive to Java programmers, so we got it.
Is it really just to win over Java programmers?
I'm exaggerating, right? I think it's a valid feature, but yeah, that's a valid concern. Okay, are there any other questions, anything online? You guys are laughing at me. Oh, okay. So we're trying something new. It turns out that I think maybe 5 of us know this. 5 people at Intellictech know PowerShell, and 1 person pretends that they know it really well. We won't mention his name, but his initials are Mark Michaelis, and so he's decided to go ahead and do a essential PowerShell session. It's a week from Thursday. It's going to be a lunch and learn, so it's a much more sort of casual thing. But we're gonna. Oh, it's on Friday. It just got changed. It's now on Friday. I already had my lunch on Thursday booked. Okay. I'm just learning about this right now. I'm pretty sure my lunch on Friday is blocked out for Frisbee, so I'm not sure, but okay, we'll sacrifice Frisbee and we'll go ahead and do PowerShell. So I'm going to do a really introduction session on PowerShell. If you don't know anything about PowerShell, but you know .NET, this is a great session. And I am pretty clear that I think PowerShell is really powerful and it's a terrible language. So just to preface this conversation on essential PowerShell is I use PowerShell all the time. Permanently, you go in my computer, I have PowerShell open. If I use a calculator, it's in PowerShell. Like it's always there. But I really think the language has a lot to be desired. And part of that, honestly, is I've become a connoisseur of languages since I've been learning C# because I really think C# is well designed. Like there's a lot of very thoughtful experts who do language architecture, and some reason those language architects who worked at the same company, a small company in Seattle, you might have heard of them, they begin with M and N and T. Anyway, they did not consult the language experts when they designed PowerShell. They basically said, what? Yeah, no. What is? They basically said shell scripts awesome. We'll just follow whatever shell script did. And so that I think that was good. But anyway, so I think I have a love-hate. Bottom line is I have a love-hate relationship with PowerShell, but I use it all the time. And I'm going to go ahead and share sort of how to learn and what are some useful things to do with PowerShell. It's a 1 hour, 1 hour and a bit session, so it's not expected to be very long. And if people are interested, then we'll go ahead and sort of delve into learning PowerShell because it is a huge library to learn and it does an amazing amount of stuff. So that's PowerShell. It's going to be on Friday at noon, a week from this Friday. With a good mic. We're not, correct me if I'm wrong, we're not going to do this in person. It's only going to be online. So unless you happen to work for Intellictech, then you can come in person. But if you don't, we're only going to do it in person.
So lunch and learn only, second lunch well.
No, it's a lunch and learn. You bring your own lunch, right? That's standard lunch and learn. Even if you're in the office, you still bring your own lunch. Okay. Any other questions? Curiosity question. Was this worthwhile? Was it interesting? It's really hard to go and advertise a session on abstract classes and implementing. Like, what do you talk about? Like, it's real. Who on earth would show up? Whoever they are, they're really weird. But was it interesting? Was it helpful? Did you learn something? Okay. Okay. Thanks, everyone. See you next time.
Thank you.
Kevin will see you next time. I will be in Africa.
Did I get some possibility with a static list, which you've never seen it?